Hello and welcome. This is New Zealand NCEA Level 3 9A Intro to Calculus. Before we start on this problem set, I just want to review the definition of a derivative. You have f of x is your function. F prime of x this is equal to f of x plus h minus f of x divided by h as h approaches 0. This is our definition of the derivative. Let's find the derivative of x squared plus 6x plus 8. F of x plus h equals x plus h squared plus 6x plus h plus 8 minus x squared minus 6x minus 8. So f of x plus h goes all the way up to here. Then we subtract f of x to get that. And then we have to put it all over h. Now, let's distribute these. We'll get x squared plus 2xh plus h squared plus 6x plus 6h plus 8 minus x squared minus 6x minus 8, all divided by h, with h approaching 0. Now, as we can see, this x squared cancels with that x squared, so we'll cross them out. This 6x and that negative 6x cancel out. This 8 and this negative 8 cancel. So we're left with 2xh plus h squared plus 6h divided by h. Now, each of these terms has an h in it, so we can cancel this way, and we're left with 2x plus h plus 6. And now with h approaching 0, this just becomes 0. 2x plus 6. Okay, so now we have to find the tangent line at this point, 115. We have our function and we have its derivative. We know the equation of a line is y minus y naught equals m x minus x naught. Now this y simply stays y. This y naught, we have to plug it in with this point that we want to send the line through. So we can write y minus 15 equals m times x minus 1. Now we have to find m. At this point, x equals 1. So we plug it into the derivative function. So we'll get 2 times 1 plus 6. This equals 8. So m equals 8. So then we rewrite this y minus 15 equals 8 times x minus 1. Now, if you want to isolate y, you simply add 15 to both sides. Y equals 8 x minus 1 plus 15. And if you want to separate the x term from the constant term, we need a little bit more work. Y equals 8 x minus 8 plus 15. Now for our final answer, y equals 8x plus 7. Okay, now we have to find the tangent line where x equals negative 2. So we use our same formula, y minus y naught equals m times x minus x naught. Now we know x naught is negative 2, x minus negative 2, but we don't know our y naught. Here's how we'll find our y naught. We will plug in negative 2 into our f of x. So this gives us negative 2 squared plus 6 times negative 2 plus 8. This becomes 4 minus 12 plus 8 equals 0. So our y naught equals 0. So that means we can just write y equals m times x minus negative 2. Now we have to plug in our negative 2 into our f prime of x to find the derivative or slope. 2 times negative 2 plus 6. Negative 4 plus 6 equals 2. Y equals 2 times x plus 2. Y equals 2x plus 4. And there's our answer. At what point on f of x is the tangent parallel to the line y equals 3x plus 4? That means that our f prime equals 3. 2x plus 6 equals 3. 2x equals 3 minus 6, negative 3. X equals negative 3 over 2. This is our x coordinate. Now we plug this into our f of x to find our y. So we'll get negative 3 over 2 squared plus 6 times negative 3 over 2 plus 8. This becomes 9 over 4. Negative 3 squared is 9. 2 squared is 4. Plus, this becomes negative 18 over 2. That becomes negative 9 plus 8. These two can combine into negative 1. So you have 9 over 4 minus 1 equals 5 over 4. So we know the point is negative 3 over 2 and 5 over 4. That is the point at which this is parallel to this. Question number 2. When is the function f of x equals 9 minus 36x minus 3x squared plus 2x cubed increasing or decreasing. To figure that out, we have to take the derivative. I assume you know the power rule. So y prime equals the derivative of 9 is 0. Negative 36x, that becomes negative 36. Negative 3x squared becomes negative 6x. 2x cubed becomes plus 6x squared. This is our derivative, and we're only interested in where it's positive or negative. And so a step I've taken to simplify it is I can divide everything by 6. Well, basically what I want to do is I want to set this equal to 0, because the points at which they either stop increasing or stop decreasing, they'll be flat, which means they'll equal 0. And once I have it like this, I can divide by their common factor, which is 6. So I'll go negative 6 minus x plus x squared equals 0. Now there's several ways of solving this. We can put it into the proper quadratic form, which would be x squared minus x minus 6 equals 0. We can either use the quadratic formula, or we can complete the square, or we can factor. Here I think it's easiest to factor. What I'll ask myself is, which two numbers add up to negative 1 but multiply to negative 6? The factors of 6 are simply 1, 2, 3, and 6. The ones that have a difference of 1 would be the 2 and the 3. So I'll just write this for the moment. Because this is negative, it means that the greater number needs to be negative. Negative 3, positive 2 equals 0. As you can see, x times x equals x squared. Negative 3x plus 2x equals negative x. Negative 3 times 2 equals negative 6. So we know the 2 points on the curve where it's flat. So that would be at x equals 3 and at x equals negative 2. So the only thing we have to figure out now is in which general direction it goes. So I'll just kind of draw it right here. We have our negative 2 and our positive 3. And let's see what happens if we plug in something that's less than negative 3. Let's say we use something like negative 4. Negative 4 minus 3 would be negative 7. Negative 4 plus 2 would be negative 2. Negative times negative, that looks like this is positive up here. So it looks like it's going like that. Now, if we plug in something between here and here, like 0, we can see that we would get negative 3 times positive 2 equals negative 6. So we get something in the negative range here. And then if we do something that's quite positive, higher than positive 2, we'll get positive times positive, and that will be positive. So we can say that since this is the derivative, has a positive derivative where x is less than negative 3. So it's increasing. If x is less than negative 3, It's also increasing if x is greater than 2, or x is greater than 2. Now it's decreasing if -3 is less than x, and if x is less than 2. Question number 3. The function f of x equals 6 plus x minus x squared has a stationary point at x equals question mark. Describe its nature. So first, let's find the stationary point, and I'll define it by saying station. Think stationary, or think of a train station. The station doesn't move. At a stationary point, the function doesn't move, but rather stays flat. This means that our derivative equals 0. So let's take the derivative. 0, the derivative of x is 1. The derivative of negative x squared, negative 2x. This is our derivative. We set it equal to 0. Let's add 2x to both sides. 1 equals 2x. Therefore, x equals 1 over 2. This is the location. It's at x equals 1/2. And we've already described its nature. It is flat. F of x is flat at x equals 1/2. Question number 4. An open box is made from cutting squares from the corners of a rectangular piece of metal, 8 centimeters by 13 centimeters, and bending up the sides. Find the maximum volume of the box and the size of the squares to be removed. This question will require us to think outside of the box. Basically, what we want to do is, imagine this is a piece of paper. We want to cut out a square from here, a square from here, a square from here, and from here. And then we can fold it so that we'll have an open box like this. But how much should we cut so that we can have a box with maximum volume? This requires calculus. What is the volume of our box? First of all, let's create a diagram. This is 8. This is 13. This is the length. This is the width. And let's call it x, what we are thinking about cutting out. So as you can see, this right here, this would be an x, and this would be an x as well, from here to here. And also this way, we want to take out x from here and x from there. So now let's find the dimensions of this box. The length would be 13 minus x minus x. So L equals 13 minus 2x. The width would be 8 minus 2x. And the height, well, that would be equal to x. And then for later on, we'll need some range that x could take. X x, we assume it will be greater than 0 and less than 4. If x is 4, that means the width is 0, and that means our volume is 0. So we'll just say x has to be greater than 0 and less than 4. So now let's write a function for the volume. We'll write v equals length 13 minus 2x times width 8 minus 2x times x. So first, let's ignore this x and try to work out what these brackets equate to. 13 times 8, that is 104. Minus 16x minus 26x plus 4x squared. And then we have to multiply this by that x right there. 104x minus 16x minus 26x, that's minus 42x squared plus 4x cubed. This is our volume. So whatever x we choose, this function will tell us our volume. So to maximize our volume, we need to find the derivative and set that equal to 0. The derivative of 104x is 104. The derivative of 42x squared, this 2 comes down in front, that makes it negative 84x. The derivative of 4x cubed is 12x squared. And we'll set this equal to 0 so that we can maximize our volume. Now there's quite a few different ways to work this out. You can either try factoring, I'm not sure if that would work, or you could complete the square, or try the quadratic formula. I'll go straight for the quadratic formula. I know there are common factors here, but I'm not going to reduce it. I'll just plug each of these numbers in. So I'll rewrite this 12x squared minus 84x plus 104 equals 0. A equals 12, B equals negative 84, C equals 104. Now we're going to use the quadratic formula. There's no easy way to do it. You just have to plug everything in. Negative b, that means 84, plus or minus the square root of b squared, negative 84 squared. I've got that as 7056 minus 4 times 12 times 104, which is 4992. And that's all over 2a, which is 24. Now this 7056 minus 4992, let's see, 7056 minus 4992, this is 2064. So we've got 84 plus or minus the square root of 2064 divided by 24. the square root of 2064 is 45.43. So I'll rewrite it over here. 84 plus or minus 45.4312 divided by 24. Now that gives us two solutions. We have an x equals to 5.39 if we take the positive route. And if we take this negative route, we get x is equal to 1.607. And now from earlier, we said that x had to be greater than 0 but less than 4. This optimizes the volume, but what this one does is it minimizes the volume. We don't want it minimized. We want it maximized. X equals 1.607. Now what we do, let's reread the question. Find the maximum possible volume. That means we take our 1.607 and we can plug it into our volume formula, which this gets quite hairy. So let me just do some erasing very quickly. Okay, so what we're going to do is we're going to plug in 1.607 for all of these x's here. So we'll get 104 times 1.607 minus 42 times 1.607 squared plus 4 times 1.607 cubed. Then we use our calculator. 104 times 1.607 this equals 167.128. Then we look at this 1.607 squared this is 2.582, and we'll multiply that by 42. So we get minus 108.4628. And we have to cube 1.607. Equals 4.149 times 4. 16.599. Then we just have to add up all these numbers together. So we've got that. We'll go minus 108.4628 plus 167.128. Therefore, our volume equals 75.265 centimeters cubed. That is the volume of our box. And this question is finished. Almost finished. Then we just have to find the sizes of the squares. We'll have 4 of these squares that are cut out, like that. If you want to draw the diagram, 1.607, 1.607, and we'll have 4 of these. So 4 of these. Now I believe the question is finished. Question number 5, the last question of assignment number 9A. A straight piece of wire, 12 centimeters in length, is to be cut into 2 pieces. One piece is bent to form a circle and the other a square. Where should the cut be made so that the combined area of both shapes is A, a minimum, and B, a maximum? So first, let's approach it from this angle. So we have our length, it's 12, let's call it L. This is our length. Let's find the relationship between a length of a circle and an area of the circle. The length, of course, is the circumference, which equals 2 pi r. So we'll say L equals 2 pi r. And the area of a circle is, so we'll write area of circle equals pi r squared. So as we can see, we can rearrange this. If we want r by itself, we can say r equals L divided by 2 pi. So this is our r. R is L divided by 2 pi. The area of a circle is pi times this squared. So pi times L over 2 pi squared. That means pi times L squared over 4 pi squared these pi's cancel and we're left with L squared divided by 4 pi. This means that however much of our 12 centimeters we devote towards the circle, our area will be L squared divided by 4 pi. This is the area of the circle. Now, for an area of the square, whatever we assign to form the square, let's use our L again. Our L would be our perimeter of the square, which is 4 times the side. Our width is L over 4. And our area of the square is simply the width squared. So our area of our square is L squared over 16. So here we have 2 equations. Whatever we assign to the circle, our area is L squared divided by 4 pi. Whatever we assign to the square, it's L squared over 16. Now, if we want to maximize the area, it would make sense that we would assign all of our length to the circle. The circle is the best shape for maximizing the area. So to find our maximum, our answer is all to the circle. That's our answer for maximum. We assign it all to its most efficient use, which is the circle. Now for its least efficient use, now as we can see, the square is a less efficient shape than the circle. So your first instinct might be to say, okay, if we want to find the minimum area, let's just assign all of our string to a square. Yes, we'll make a big square, but we won't make any of the circle, and the circle's efficient. So maybe you'd think, let's put it all to the square. But there is an even less efficient system to use, and that is a combination of the circle and the square. Here's what I mean, is I'll say C, I'll create a variable, we'll call it C. This is the length assigned to the circle. And then it means I'll create another variable, 12 minus C. And this is our length assigned to the square. So here's what I'll do. I'll assign C into here for L, and I'll assign 12 minus C into here for L. So we've created our C for the circle, our 12 minus C, which gets assigned to the square, and we plug these in. Now we could assign this to the square as and this to the circle, but either order works. I've chosen this order. So for the circle, we'll get C squared over 4 pi. For the square, we'll get plus 12 minus C squared over 16. This is our total area. So now to optimize it, or in this case, minimize it, find the lowest point, we have to work this out and solve. So now we plug it in. For the circle, we found we get C squared over 4 pi. And for the square, we get 12 minus C squared over 16. This equals our area. Now we'll distribute this 12 minus C squared. So we'll get C squared over 4 pi plus 144, 12 squared, minus 24C plus C squared divided by 16, and this is the total area. Now our next step is to differentiate. We can go right ahead and differentiate. This comes right out in front. We get to 2C over 4 pi. We differentiate with respect to C. The derivative of this here is 0. This becomes negative 24 over 16. That becomes negative 3 over 2. And this becomes plus 2C over 16. And we want to optimize it, so we'll say it equals 0. So now we just have to solve this. Just a little bit of algebra. So what I'll do is I'll put this negative 3 over 2 onto the other side. So I'll get 2C over 4 pi plus 2C over 16 equals 3 over 2. Now we can divide both sides by 2 and get rid of this and this. So we'll change this to a 4. And we can get rid of these two c's. Our c over 4 pi plus c over 16 equals 3 over 4. What we can do is find a common denominator, 16 pi, and we can multiply everything by that. So we'll get 16 pi c over 4 pi plus 16 pi c over 16 equals 16 pi times 3 over 4. Now we can cancel here. These pi's cancel. So we're left with 4c. These cancel. Plus pi c equals, these cancel, 12 pi. Then we can factor out the c. C times 4 plus pi equals 12 pi. C equals 12 pi divided by 4 plus pi. And if you have a calculator, type it all in. You'll get C is equal to 5.2788. That means that the length devoted to the circle should be 5.2788. Now devoted to the square, you'll get 12 minus 5 . So to the square, you'll need 6.7212 for the square. So to the circle, give 5.2788, and to the square, give 6.7212 centimeters, and then you'll have a minimized area. So what you'll have is you'll have a small circle and a small square. This is the most inefficient outcome you can hope for. And that is the assignment. Yay!